Hello, everybody. Welcome to the Ask Me Anything session on on-device machine learning in mobile and web apps. My name is Arun Venkatesan, and I'm the product manager of TensorFlow Lite and the model optimization toolkit. I have with me Christiaan and Sandeep. Christiaan and Sandeep, would you first like to introduce yourself?
Hi, my name is Christiaan Prins. I'm the product manager for MLKit, and I work in the Android org. It's nice to meet you. I'm very excited to answer your questions today.
Hi, everyone. Thank you for joining us. My name is Sandeep Gupta. I'm a product manager in the TensorFlow team. I work on machine learning for the web and for cloud. Very excited to be here and talk to you about on-device machine learning.
Thanks, Christiaan and Sandeep. So to everybody that's here, thank you very much for your time. Please don't forget to post your questions. You can just tap on the Q&A icon to the right side of the live stream video. And then you can also post and also vote on the questions. And then we'll just pick the most voted questions to answer. And so please support your favorites. Cool, let's get started. So we have a user asking us, what is on-device machine learning and why should I care about it? Christiaan, do you want to go?
Yeah, sure. Let me tackle this one. I think traditionally ML was something that you did in the cloud. So we ran. So typically you would run these kind of big and compute-intensive models on cloud servers. So in 2015 we launched the TensorFlow framework to kind of support that way of using ML. In 2017, we extended that with TensorFlow Lite. So TensorFlow Lite made it possible to actually run these models on device. So at that time, we also launched a converter that allows you to convert these bigger cloud-based models into models that you could run efficiently on device. And that made it possible to now run ML on mobile devices, also on desktops and laptop computers, and also on embedded devices. So why would you want to run machine learning on device? Well, there's a couple of reasons. So models on device typically have very low latency. So you can, because you don't need to send the data to the cloud, you can do everything local. You can run inference within a matter of milliseconds. So you can process a frame of video or a piece of audio in real time. And so it's not just that the latency reduces, but it also unlocks new use cases that you can make use of as a developer. So for example, you can process a camera in real time and take action on things in the real world. Like, for example, we do in the Google Lens app, where you just point your phone at, for example, at a piece of text and you can interact with it, or you point it at a barcode and you can scan the barcode. So that's one big reason why on-device ML is interesting. Another reason is that the processing happens fully on device. Like, you don't need to send the data to the cloud. It also means is that you can, process content that may be, more sensitive and that you actually don't want to send to a server. So you can do all the processing locally without involving a server. Naturally, it works offline, like you don't need to be connected. Also means that you don't need to send data to a server, so you can keep, you have a limited impact on the data plan of your users that they typically care about. And lastly, also it's a way to offload servers. Like, you don't need to maintain servers for ML that you run on device. So for some use cases, that can be of a benefit. Sandeep and Arun, anything you may want to add here?
Yeah, Christiaan, I had a quick question for you. You used the word inference. Can you explain a little bit more what inference means?
I think maybe you can answer that one.
Sure. Yes, I can. Sounds good. Yeah. So inference is basically, Christiaan used the word he said when you do model inference. So inference is basically passing some data to the model and getting a response, right? So if your model is an image model, you pass data and get a response. For example, what are the labels in the image and so on and so forth. So I think that's important to explain. Cool.
So it's basically, maybe to add, it's basically just running. You have a TensorFlow Lite model and you run it. So you have inputs, you run the model, and you get the outputs, and that's what we call an inference, right?
Yep, exactly.
Cool.
Sounds good. So here we have another user asking about some of the most common use cases where ML is being used on device. Sandeep, do you want to take a shot at it?
Yes, absolutely. So I think there are many applications where, just for exactly the types of reasons that Christiaan just talked about, doing on-device machine learning is particularly useful. So, because you have these devices like mobile phones that are in the hands of pretty much everyone, you have easy access to things like a webcam on the phone or sensors such as microphone on the phone. You can do lots of things where you can sort of interact with the real world, right? You can imagine taking a picture of a scene and recognizing what object it is, help with understanding your surroundings, help with understanding what am I interacting with, or recognizing sounds and classifying sounds, and then use that to drive interactions. So there are many such applications where image-based or audio-based applications where many companies, enterprise, lots of users are trying to use these. We have examples of companies such as L'Oreal, for example, which are building virtual product try-on applications. So in e-commerce and retail, folks are using this. Text is another huge use case. So anytime you have user-generated data on a device, you could process that. Features that you are familiar with, such as Smart Reply or Auto Compose in things like Gmail and other text compose applications, all of these can potentially take advantage of on-device ML.
Yeah.
Thanks, Sandeep. Christiaan, anything to add? Go ahead.
Yeah, maybe to add, like one use case that probably a lot of you have used is in kind of self-expression apps like TikTok or Snapchat. All the filters are pretty much powered by on-device ML. So they detect, the pose, they detect the face, they maybe interact with text. There's maybe style transfer to convert how the kind of the video feels. Like it converts it into something more artistic. And that's all where on-device ML is being used today already. It is also being used for much more subtle features. Like, for example, in Android, when you click on a piece of text, you know that it auto expands to the larger selection. And that is being done with ML. Like ML looks on what is the right entity in this text that you may want to interact with, because you maybe didn't intend to click the word, but you intended to click the address or the phone number or the URL. And so an ML model runs and expands the selection to what makes sense for you, and then you can take an action on that. And that's powered by ML. It's very subtle, but ML really makes a difference there.
Thanks, Christiaan and Sandeep, for the great examples. Some of the examples from Google apps that use our ML are Google Lens, for example, that will help you understand the world around you using your camera. And then the Google Lookout app, which scans and it's an accessibility app, which scans and transcribes the world around you using object detection, image classification, text recognition, and so on and so forth to help people that are visually impaired. Cool. And there's plenty more examples that we didn't cover here, but you can find more information in our website at g.co/on-device-ml, and we'll publish that later on. Cool. We have another web application developer here, Nitish, asking us a question. Sandeep, it's probably right in your territory. We've seen on-device ML in Android devices, but what about web apps? For example, will on-device ML work as usual in PWAs?
Yeah, thank you for asking, Nitish. Great question. So absolutely. I think ML on device in web applications is a really, really exciting field, simply because, the mobile web browser is available on all of these billions of devices, and your users can be using ML-based web applications without having to install anything. So we definitely support that. TensorFlow JS is a library which is part of the TensorFlow ecosystem that has all the tooling you need to take a machine learning model and run it in your web application. There's very easy JavaScript APIs which let you load a model and run prediction on it with just a couple of lines of code. You can check out all of our documentation on that. At this I/O, we recently announced a really exciting new feature by which you could take, if you have a mobile app already, and if you are using a TensorFlow Lite model, you could take any of your TensorFlow Lite models and just directly run them in a web application. So it will work in a PWA, it will work in an Angular or React-based application, and so all of that is supported. I sort of encourage you to check out our documentation and our sessions here at IO on this.
Cool. Thanks, Sandeep. We have Thanatas, a user, asking about model protection. So the first part of the question is, I believe that on-device machine learning means having the model on-device and loading it beforehand. So how can we prevent other people that use our product to extract that model from extracting that model, I guess? I can take a shot at this. So first of all, I think there's a few details around the first part, right? You don't have to, you can package your model as part of your Android or iOS app. You can pre-package it, but you don't have to do that. One thing you can consider is packaging your model as part of or hosting your model on Firebase hosting, and then using Firebase's SDK in order to download and manage your model on device after the installation of the app, and that helps you keep your app size smaller. The other option is to use Android app bundles, which lets you deploy artifacts to your apps post-installation. And so again, it helps you keep your app small at installation time. But the second part of your question, I think, is an important one. So how can I protect my models from being stolen? Essentially, right? We're actively thinking about this. You can make it harder to steal models via encryption and other mechanisms. Part of the things that we're thinking about is to make it even more harder for others to access your model. Some things you could think of is just maybe run part of your model on device and send the proprietary part maybe to the server side, and then model alone may not be the secret sauce in your applications, right? There might be other things and so on. But do watch our public channels for updates on this. Cool. So we have Dino asking about on-device training and federated learning. So I can take a look. I can take a shot at this. Yeah. Thanks for your love. He says love from somewhere. Okay. So the TensorFlow Lite team is actively working on device training in TensorFlow Lite. So the key point here is that until now, you could TensorFlow Lite, you can mainly do inference on models, but obviously we have increasingly heard developer need for on-device training features, and so we already have a small working prototype that you can find when you search for it. But we are actively working on it, and we expect to deploy an end-to-end working collab maybe in the third quarter of this year. And then so that'll be for on-device training. We have some early thoughts on federated learning as well, but I think our primary deliverable for this year would be focused on device training. We would love to hear your thoughts on, for example, your specific needs around federated learning and so on and so forth. Cool. Let's see. Besides processing power, are there any other advantages to using on-device ML? When should you implement on-device ML instead of cloud ML? So I think Sandeep, go for it.
Sorry, Arun. I think the question is, are there any other disadvantages to using on-device ML?
Yes, there you're right. Yeah.
I can take this one. So, I mean, we realize that you need to you can make a choice on where to run your workloads. And I think for the cloud, when you need to run very big and complex models, I think the cloud is probably the right place to do that. However, on-device unlocks new capabilities that you cannot do in the cloud. So you should not see it as, okay, we can now have on-device ML, we can move everything off servers. No, it just provides an additional capability. And typically, actually, the combination of on-device and cloud may work best. So I can give an example. we worked with Adidas on doing visual search in their stores. So at the moment, you can pick up the Adidas app, go into one of their stores, and actually point the phone at a shoe. And we run Ondevice ML to do object detection and track it in space, and do coarse classification of the object. And then the crop of that object is being sent to a visual search backend, where we run an ML model in the cloud that matches the image to one of the items in Adidas's catalog. So in this case, we use the benefits of both sides to kind of create a much better experience. Because in the end, the user gets a much more seamless, interactive experience than if you would just ask them to snap a picture and directly send it to the backend. Do you want to, Arun or Sandeep?
I want to just quickly jump in and add one thing about sort of not so much a disadvantage, but a complexity for on-device ML that you need to be really aware of, is that because of the wide variety of devices and the different types of hardware accelerators and all the different configurations that are there, you need to be very careful about how your model does. And you just need to do more work in testing and checking how your model performs on all kinds of devices. And those are some of the factors that are very much in your control when you are not in a device setting or you are in a server setting, right? But in the TensorFlow ecosystem, we offer a lot of tools to help you with that.
Yeah, thanks, Sandeep and sorry, go ahead, Christiaan.
No, that's go ahead.
Yeah, so in addition to what Sandeep and Christiaan said, I think especially when you develop custom models from scratch, there's a lot of subtleties there, right? For example, you need things like, you need to make sure that your inference doesn't consume a whole lot of power, or you need to make sure that it runs, you need to have a good idea of the performance of different types of devices. And then you need to make sure that your model is optimized to fit within the various high-end and low-end devices. And so, as Sandeep and Christiaan mentioned, we have various tools in the TensorFlow ecosystem to help you with some of this stuff. In addition, also take a look at the model optimization toolkit, which is a set of tools and APIs to help you optimize your models to deploy on mobile devices with constrained resources. And so we have techniques like quantization, which will help you reduce your model size to about 25% of the initial float model, and so on. And also smaller models are more power efficient and so on, right? So more than disadvantages, I think, like Sandeep mentioned, these are all constraints or challenges when you deploy your on-device machine learning models, when you deploy your cloud models on device. Cool. Thanks for the question. Yeah, go ahead.
Maybe we can do a kind of a shameless plug. Like, we just launched a website where we bring all the on-device ML solutions from Google together. So if you want to know more about all the tools that we're talking about here, please go to g.go/on-device-ML, so on-device-ML. And we tried our best to kind of make it clear for you on what we all have available, what tools you can use, or what turnkey solutions you can use. And that should help you on your journey on using on-device ML in your apps.
Cool, thanks. So we have Dean Cowley asking us, in the What's New in Machine Learning, Sarah mentioned that on-device training is on the roadmap. When will this become available, and how will the average training time compare to training in the cloud? That's a great question. So I think we shared some of that earlier. We expect it to be available the latter part of this year, and then there'll be a end-to-end collab that'll be published. And so definitely run through it and leave feedback on the website. How will the average training time compare to training on the cloud? So we expect that most of this training will not be done from scratch, but it'll primarily be retraining or refining the already trained model on device. And so the training time really depends on your use case. But part of it will also be a set of APIs that we might add, for example, that let you restrict the training time to, let's say, 10 minutes or whatever. But anyway, those details are being finalized as we speak. So definitely watch out for updates on our public channels. Cool. Let's look at the next one. MLKit and TensorFlow Lite appear to have some similarities. Can you provide some guidance around when to use MLKit versus TensorFlow Lite? Christiaan?
I mean, it may look a little bit confusing at the beginning, but it's actually fairly straightforward. So as Google, we realized that ML can be fairly complex. And as Google, we have trained a lot of really powerful models that we also use in our own apps. So with MLKit, we decided to kind of take all the models and combine them as part of an easy-to-use SDK. So we do all the testing with the models, make sure that they run well across devices, that you get good accuracy, and then we offer those as simple-to-use APIs. So with MLKit, you just in your app, you just declare a dependency on MLKit and then integrate with it, and you just use it like any other API. Now, TF-Lite, like MLKit under the hood, uses TF-Lite, so TensorFlow Lite. It has TensorFlow runtime. We use TensorFlow Lite models. We use pipelining frameworks like MediaPipe. But if you need to build something more custom, like we offer the tools like the TensorFlow Lite runtime, the TensorFlow Lite task library, and MediaPipe, so that you can build those solutions yourself. So with when you use TensorFlow Lite, you typically take one of our models and you either do transfer learning or you build a model from scratch and you train it. And then you run it either directly with the TF-Lite runtime or with the task library, which makes it easier for common scenarios to kind of run a model on device. So I think that's the difference. Is really the distinction between an SDK that you can just pick up and integrate in your app for common use cases. And then if you need to build something more custom, something that kind of, it's a differentiator for your product, and you want to build an ML model that will really lean into that differentiator, then we have TensorFlow Lite and the whole TensorFlow toolset.
Thanks, Christiaan. Just to add to that, in the latter case that Christiaan was mentioning about, when you have a custom model, invariably one aspect of using a custom model within an Android or iOS app is you need to convert your in-app data or in-app data structures to the tensors that the model takes. So that's the model inputs and the model and also the model outputs, right? And so we have the TensorFlow Lite task library, which is essentially pre-built APIs to help you with inference in just a few lines of code. We currently have that for Android. And so for some of these most common use cases, for custom models, you can use the task library where many of these utility methods are abstracted away from you, and you don't have to deal with byte buffers and things like that. But as Christiaan mentioned, you have to almost always start with to see if turnkey solutions exist for your use case, and then go over to the custom side if these are not available for you. And also, the other quick point I wanted to make is when you go over to the custom side and you've decided to build a custom model on your own data, you can use the TensorFlow Lite Model Maker, which is a tool that will let you customize models, retrain models with just a few lines of code. Take a look at our website. Cool. Let's move on to a question from Tarinda Dishan. Will concepts like edge computing affect on-device ML? Will it be a positive or negative impact? So maybe I can take this quickly. So on-device ML is just a form of edge computing, right? When we think about edge devices, we think about anything that doesn't run on the server side. This includes mobile devices, Raspberry Pis, microcontrollers, web, Linux devices, desktop, etc., etc. So I think they both are the same. On-device, there is a few terms here that are conflated with each other, but I think for the most part, edge computing is running things that where you don't make a server-side call and get back a response, but run it on device. Cool. Sandeep, this one from Nitish. Oh, sorry, Christiaan, did you want to say anything?
Well, the one thing I wanted to add, I think maybe edge computing also could mean that things get more pushed to the edge, right? So in CDN networks, you might push more computing to the edge of the cloud. I mean, so when we talk about edge, we could either say on device, but edge computing, like edge TPU for us could run in a device, but also could be an edge of the cloud or edge of the network. I mean, I think we're not arguing for doing ML just on device or just in the cloud. We think each of these technologies have their pros and cons. We just want to highlight that on-device ML unlocks unique use cases or unique capabilities. So, for example, if you need to process data and it needs to stay on device, you don't want to send it off device. You want to keep it on device, and that's where on-device ML can help you to still build or offer powerful ML-powered features. And that's harder if that's not possible if you rely on cloud on cloud ML.
Got it. Thanks, Christiaan. Sandeep, we have one for you from Nitish. Adding to the previous question about models getting stolen, how should one handle this in the perspective of users' privacy in on-device models for the web, since on web it's pretty much accessible easily? Any thoughts on that?
Yeah, thank you. I think a lot of the security and privacy considerations that Arun talked about earlier, they all apply here. And web being such an open platform, this is certainly a concern. I think on the point of users' privacy, the fact that you can run a machine learning model in the browser client side actually helps with that, because your user data, whether it's text generated data or image data from webcam or something, that doesn't need to be sent to a server, right? So a lot of the things can be kept on client side. So that's actually an opportunity from a privacy point of view. But still, from a security point of view, definitely those challenges are there. And we are looking at techniques that Arun mentioned earlier about trying to see if encryption can be used, trying to come up with clever ways of running things in a combination of server side and device. And we're sort of very, very interested in chatting with you all, the users and community, on this. I encourage you to sort of join our mailing list, discussion forums, and sort of help start a discussion on this topic. If you have ideas, needs, questions, it'll be great to kind of look at this even more.
Thanks, Sandeep. The next question is, my model is huge and I would like to reduce its size before deploying it on my mobile app. How do I do it? So I think we covered some of this, but I think the key point here also is that if you're new to ML and if you're looking for a model, definitely take a look at TensorFlow Hub. TensorFlow Hub is the website for a list of our curated, pre-selected models, which are contributed by Googlers as well as other open source contributors. And then you can pretty much find a lot of models there that might already meet your needs, which are quantized, which are optimized, etc. In addition, I think we talked about some of the optimization techniques as part of the model optimization toolkit. And so definitely try those out. And +1 to Sandeep's mention about please engage with us on our forums, on GitHub, etc. We actively monitor those, and then we'll try to address as many issues as possible. Cool. We have a question from Tom. Could you tell us a little bit more about on-device ML on embedded devices, microcontrollers? What are some minimal specs, timelines when it goes GA, etc.? So maybe I can take this one. So we already have TensorFlow Micro, which is in production. You should take a look at the code lab that Pete Warden ran as part of I/O. If that session is already not passed, otherwise you can just catch it on YouTube. And then we have a lot of internal Google apps that already use Micro. So the best example of TensorFlow Micro in production at scale is the hot word detection, the OK Google hot word detection that runs on TensorFlow Lite Micro. So it is already in production. And then there's a lot of interesting use cases that we have sourced from partners and other developers that use Micro. So please take a look at the website. Cool. We are winding. Cool. Thank you so much. I think we had a lot of interesting questions. Thank you all for your active participation. And then again, let me add on to the shameless plug. Please take a look at g.co/on-device-ml. That's the new website that we have, which brings together all of Google's on-device machine learning products and explains the right type of solution that can help you with your on-device machine learning. Thanks again for your time. We really appreciate it. And please stay in touch through GitHub and other public forums. Thank you.
Thank you.